Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled An Improved ML Approach for Detecting Patients Using EMG Signals. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the applications that we have designed for the biomedical application by using the artificial intelligence. So in this, basically we are developing one of the system in which we are evaluating multiple classifiers on the machine learning basis for the patient disease detection, right? So here the signal processing is also one of the things that we are using into it. So let's move to the video. Before moving to the video, let's talk about that what we will cover into this. In this video we will initially talk about that in which application areas the proposed system can be implemented and is useful. Then we will talk about that what codes we are going to provide and which files you need to execute, along with the software requirements and the library requirements. Along with that, we will talk about that what exactly the current systems are, or the current researchers are working in the same domain, followed by the problem identified in those system and what exactly the proposed system is doing. Finally, the experimental outcomes and findings will be discussed and will be shown. So let's move to the application areas. So as this domain is related to the patient's health and all, so this is particularly designed for the biomedical application for the medical health cares. So in order to show that what exactly the role of AI is there for the healthcare, we are developing this system where the ECG based systems and databases has been used in order to identify the patient's health. So let's move to the code demonstration, that what code and how you need to execute it. So the folder that we are going to provide will be like this, under which you can see there is a folder named code, and all the files are present in that particular folder along with the dataset. The dataset that we are using here is basically the ECG dataset which we have collected by our own and as well as from the online platforms. So the whole code is being designed in the MATLAB, so you must have the MATLAB software with you. The MATLAB version that I'm using is here R2019A, so you can use 2018 or above any of the version, but make sure it should be a full version or the trial one. So the dataset for the ECG you can get from the internet. It is easily available on the UCI Machine Learning Kaggle. So you can see here ECG dataset. So you can easily get it from the Kaggle. You can get it from the physionet.org and even on the UCI Machine Learning. So these are the two main platforms from where you can get the data for the different ECG with the labeled information. So we have used it from the physionet as well as we have collected from the hospitals also. So in order to run the code, you just need to go to the folder where the whole code has been placed. So you just need to copy the path of the folder from here, right click, copy, go to the MATLAB and paste it here, Control V, enter. You can see or whatever the files were there in that folder are easily shown in the current folder. Out of this, you just need to run main code.m file, press enter. When you will press enter, you can see it will be ready to be executed. Here on the top you can see there is a run button, a green play button, on which you just need to click run and it will start executing the code. So I'm going to click on the run button, and in the meantime we will discuss that what exactly the current systems are doing and what are the issues with them and what we have done. So I'm clicking on the run. You can see it start executing. So most of the people, those who are working in the domain of the ECG signals or any image related data for the biomedical applications, they are the facing issue like extracting the features, that how we need to extract the features. Secondly, as the signals are very crucial and you can't skip any important information, and it also having a lot of information with us will be challenging when it is about that which features are to be used, which are not to be used. So the AI models are basically dependent on if only the useful information, as much useful information will be given to the networks, that much accuracy will be there. So the main challenges with the current systems were that initially the feature extraction methods they are using are very common and having restricted with some certain things. Secondly, the selection of the features playing an important role. Thirdly, which classifiers can be the best option. So without understanding their outcomes and analyzing their outcomes, it is hard to identify that. So in the proposed model, what we have done, we have implemented certain things, and also more than one classifier has been used in order to identify and show the effectiveness of the machine learning methods. So in this method, what we have implemented, let me enter this training percentage. Let me I'm entering 70% press enter. Then it will ask me for the testing, that is 30, and press enter. It will start processing and will execute the results and will show the outcomes. So we will talk about the results later on. In the meantime, let's talk about what we have done. In the proposed method, what we have done, we have read the whole data set. The data set that we are having with us is here. These are around 66 patients data. So we have read the data, and after reading the dataset folder, every data is being read because that data is basically a .dat file, which is database file. After reading that, we are taking the number of samples from the signal because the input signal is very much lengthier. So in order to reduce the length, we just take a sample of around 408 samples. So then we are applying the wavelet decomposition in order to get the information of the approximation coefficients and the detailed coefficients, which are helpful also in extracting the peaks of the ECG signal. So here we are using SVT instead of discrete. So we are using SWT. So most of the people are using the DWT, that is discrete wavelet transform. So here we are using stationary wavelet transform. So this is one of the change that we have made. Then after extracting the coefficients, we just need to segregate them. So we are applying fuzzy C-mean clustering in order to cluster the data so that whatever the coefficients we got, we can group them in a set of features so that further information can be easily extracted and it should be more precise. Then after that, we have applied number of feature extraction parameters, like that includes mean, standard deviation, variance, and all these factors. After that, we are applying the hybrid of PC and LDA algorithm. So PC and LDA are the feature algorithms. Those are used to reduce the feature length as well as to provide more accurate feature sets. So those features are finally saved in a variable. Later on, as the set of the feature is big in count, so we have applied the infinite feature selection method to select the best weighted features which are greater than the mean of the weights that we have achieved from the features. After that, finally, we have applied three different classifiers. One is ANN, another one is PNN, and third one is SVM. So we are training them with the percentage of 70 30 80 20. It is totally depend upon you that how much training and how much testing data should be there. And finally, we are calculating the parameters including accuracy, sensitivity, specificity, precision, recall, and F1 score. So the results that we have got, let's see that. So initially when data is read, you can see this is the actual signal that we have read from the data set, which is when processed we got the in the normalized form. And because the peaks are very much different in that, so we just normalize the data, and then we have applied the SWT in order to get the coefficients from the signal to get the more refined information. Then the clustering from the fuzzy C-mean is been applied in order to identify the grouping. Then PNN, ANN, and SVM has been applied in order to get the results in terms of accuracy. This is for accuracy curve. This is for sensitivity, specificity, and so on. Even the graph, other than the graphical results, we have also shown it in terms of the tabular form, where you can see the ANN is achieving highest result in comparison to PNN and SVM. So ANN is artificial neural network, SVM is sport vector machine, and PNN is basically, here I can show you the PNN. So PNN is basically probabilistic neural network. So we have used probabilistic neural network. So the three of the algorithm we have implemented and concluded that ANN is providing better results by the proposed method and achieving up to 94% of accuracy when 70 and 30% of data is given for the training and testing. So further modifications are still possible and the much complex system can be implemented in order to increase the accuracy further. So for those details, you can contact us directly and can get the details. Thank you. Thanks for watching.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.